Today, we are diving into one of the absolute biggest challenges in modern cloud security. How do we secure our applications when we have to assume the network is always hostile? Well, it means it's time to finally get rid of the digital skeleton key, for good. So just imagine for a second, a single key that could unlock every single door in a massive skyscraper. That is exactly what a static, long-lived credential, like an API key or a private key, becomes in the cloud. As our source material puts it, just one compromise can turn into a skeleton key, giving an attacker access to, well, pretty much everything. The stakes really couldn't be any higher. So, if storing keys is the problem, how in the world do you secure the fortress without using any keys at all? I know, it sounds like a riddle, right? But it's the exact challenge that this whole new security paradigm is designed to solve.
To get there, first we really need to understand the enemy. So we're going to break down precisely why these static, long-lived credentials create such a massive and, let's be honest, an untenable risk in the dynamic, sprawling cloud environments that we all work in today.
A stolen key isn't some abstract, hypothetical problem. It leads directly to an attacker stealing your data, hijacking your compute resources for stuff like crypto mining, or just moving sideways from one system to another. It even opens you up to supply chain attacks and that classic confused deputy problem, where a totally legitimate service gets tricked into misusing its own authority for an attacker.
For decades, we've relied on managing these persistent private keys and API tokens. This is the old way, the fragile way. It's a world of complicated secret rotation schedules, credential sprawl, and just that constant nagging fear of an accidental leak.
At its core, the traditional model was built on a simple but really flawed idea. A workload's identity is proven by a private key that is physically stored on that workload. This means the very thing that proves its identity is sitting right where an attacker can just take it. The entire system's integrity hangs on keeping that one key a secret. And when you put them side by side, the contrast is, well, it's night and day. The old way relies on static keys, stored on the workload, implicitly trusting that key for potentially years. And the result? A catastrophic blast radius if it's ever compromised. Now we're about to dive into the new way, which flips every single one of these on its head. So, welcome to the new way. It's all built on the philosophy of zero trust. And this is a fundamental paradigm shift. It is not about building a bigger wall, it's about assuming the attacker is already inside the wall and then acting accordingly. The core idea sounds simple, but it is so powerful. Never trust, always verify. In a zero-trust architecture, there's no such thing as a trusted internal network. Every single request to access a resource has to be individually authenticated and authorized every single time. It's a relentless level of scrutiny, but it's absolutely necessary. Okay, so how do we make this practical for our applications and workloads? Well, the technology that makes all this a reality is called Workload Identity Federation, or WIF. And crucially, this isn't some proprietary, locked-in system. It is built on proven open standards like OpenID Connect, which means it works across different clouds. So how does this secretless magic actually happen? We're about to walk through the 5-step flow that completely replaces the need to store a static key on a machine. Ever. All right, before we see the diagram, let's just break down the logic. First, the workload gets a temporary ID token from a local provider that it trusts. Second, it takes that token and goes to exchange it with the cloud's Security Token Service, or STS. Third, the cloud STS checks if the token is legit. Fourth, if it all checks out, the cloud issues a different native short-lived credential. And finally, the workload uses that new native credential to do its job. And this diagram shows that whole flow in action. You can see the workload on the left asking for a signed JWT, that's a JSON web token from its OIDC provider. It then presents that JWT to the cloud's IAM system, which verifies it and then hands back a temporary native token. The workload then uses that token to access what it needs. But notice what's missing? A static key file. It's just not there. It's gone. This quote from the source research just says it all. The private key, the main anchor of trust, never exists on the host. This isn't just reducing the risk of credential theft. It completely eliminates the core vulnerability that makes it possible in the first place. That is a total game changer. Okay, so this all sounds great in theory, but does it actually work in the real world with all its messiness and scale? Well, let's look at a case study that shows how this framework moves from a research paper to a production-hardened reality. So this framework was validated at SentinelOne, a company that operates a massive real-time security platform. And we're not talking about a small test here. We're talking about securing over 100 Kubernetes clusters, some of the largest in the industry, spread out across AWS, GCP, and Azure. That kind of scale and complexity makes it the perfect proving ground for this new security model.
And these diagrams from the paper show you exactly how it works in a multi-cloud world. On the left, you've got a workload in a Google Kubernetes cluster using its native Google identity to securely get credentials for AWS. On the right, you see the reverse, an AWS workload getting credentials for GCP. This shows a single, unified pattern for all your cross-cloud access, which is just a huge operational win.
So this federated identity pattern is a powerful piece of the puzzle, for sure. But it's still just one piece. So how does it fit into a complete enterprise-wide cloud security strategy? Where does it live in the grand scheme of things?
For that, we can look at the AWS Security Reference Architecture, or SRA. Think of this as a blueprint for organizing your entire cloud estate, with dedicated accounts for security tools, infrastructure, logging, and all your actual workloads. Our workload identity pattern fits perfectly within this broader framework. It's the mechanism that secures the communication between services running in all these different accounts, making it a critical piece of the overall security posture.
So, where does this all lead? By getting rid of static credentials, we're not just closing a vulnerability, we're fundamentally changing how we operate and manage risk in the cloud. Let's take a look at the impact and what this makes possible next. And this shift is something you can actually measure. Credential lifetime drops from years to minutes. I mean, that's an improvement of several orders of magnitude. The blast radius of a compromise gets drastically reduced, and the operational burden, which used to grow with every single new service, becomes nearly constant. You're just managing a few trusted identity providers, not thousands of individual keys. And once you have this secure identity foundation in place, you can build even more powerful things right on top of it. I'm talking about things like attribute-based access control, where permissions are based on dynamic workload attributes, or just-in-time credentials that literally last only for the duration of a single task. The possibilities are really incredible. So here's the key takeaway, the bottom line. This isn't just a nice to have or some advanced technique for a few big companies. As our cloud environments just keep growing in scale and complexity, moving to a federated, secretless identity model becomes an absolutely essential component of any modern security posture. And that leaves us with one final question to think about. Every single one of your applications has an identity. Is that identity secured with a fragile, static skeleton key just waiting to be stolen? Or is it built on a dynamic, verifiable foundation ready for a zero-trust world?